The host gets to see things from a different perspective to, let's say, the storage array. For example, latency, as seen from the storage array, only shows latency incurred from the moment an I/O arrives at the storage array to the moment that it leaves again. No view of latency incurred on the host or on the network. The host, though, on the other hand, sees latency incurred within itself, the network, and the storage array, though it can't give you detailed information about network or array-based latency. But its view is more of an end-to-end view. The most popular performance tool in the Microsoft Windows world is perfmon. And as we can see on the slide, perfmon allows us to view an extensive set of host-related performance counters. On the screenshot that we've got on the slide, we show some memory-related counters in the list on the left, as well as on the right, we show that we'll be tracking some memory and some processor-related counters. Anyway, once we've decided which counters we want to monitor with perfmon, the next screen shows us what the charts look like. What we're looking at now is a screenshot of what was a real-time chart tracking several performance-related counters. And at the bottom of the screen, we can see that we're tracking 5 logical disk-related counters. These counters show us the average read and write latency on our C drive, D drive, and then the totals for C and D combined. And as we mentioned earlier, the response time shown in perfmon include network and array incurred latency, though of course it can't break it down and show you how much of that latency was incurred in the network or how much was incurred in the array, but it does give you that end-to-end view. And if you're in the Linux world, one of the most popular tools for measuring I/O performance is IOstat, and as it's Linux based, it's command line only. Now for one final point while we're talking about the host view, let's talk about partition alignment. While partition alignment isn't so much of an issue, or maybe we should say is less often an issue these days, due to the fact that most newer operating systems automatically align themselves properly, it's still important to make sure that alignment is done correctly. The basic principle behind partition alignment is to line up the logical structures of a partition with the physical structures of the underlying disk drive. The image on the slide shows us a misaligned NTFS partition on a Windows server, where the clusters in the NTFS file system aren't lined up correctly on track boundaries or sector boundaries of the underlying physical hard drive. So in this example, a read or write to either of the clusters highlighted in red would actually cause an overlap of 2 tracks on the disk drive and make the I/O operation slower, as well as creating more work for the disk drive. As a comparison, let's now show how the two should be lined up. As we can see, no clusters in the NTFS file system overlap underlying hard drive tracks. Anyway, let's move on to the array and look at some simple charts and metrics from the array's perspective.